All right, so this is section 5.3. We're talking about the incenter and the circumcenter. So before we start talking about our triangles, we need to talk about a couple of vocabulary words. Concurrent. So we need to know what concurrent means. Anybody have an idea? In everyday language, when we say things are concurrent, what do we mean? They're the same. Concurrent usually means they're happening at the same time. We arrived at the building concurrently. Mr. Beamer and Mr. Leader have classes concurrently. It means they happen at the same time. We're going to use it in kind of the same way. But what we're going to say concurrent means is when three or more lines meet at one point. So that's what we're going to say for now. That's how we're going to use the word concurrent, where three or more lines are meeting at one point. We call the point the point of concurrency. So three or more lines are meeting at this point. We say they're concurrent. The lines are concurrent. The point where they meet is a point of concurrency. So what we're talking about today, the incenter and the circumcenter, are points of concurrency in a triangle. So we're going to talk about the circumcenter first. The circumcenter, we're going to say the perpendicular bisectors and before we write more, let's remember what a perpendicular bisector is. What do we mean when we say perpendicular bisector? Cross at a 90-degree angle and the bisect part in the middle. So we're constructing the segments that cut the sides in half and make a 90-degree angle. Perpendicular means 90-degree angle. Perpendicular bisectors of the sides of a triangle are concurrent at a point. And this point is equidistant. And what's equidistant mean? Equal distance, just like it sounds. A point equidistant from the vertices. So if we have the perpendicular bisectors of the sides of a triangle, they all meet at one point, and that point is the same distance from each vertex. The point is the circumcenter of the triangle. And the reason we call it the circumcenter, it is the center of the circumscribed circle. Circumscribed, I'm going to put in parentheses, means drawn around. So it's the center of the circle that fits exactly around the outside of the triangle. It's going to touch each vertex. So let's draw a picture of the circumcenter. So we have a triangle, some triangle, and I know my picture is not necessarily going to be perfect, but I'll try to get it as close as I can. So we're going to construct a perpendicular bisector. We're going to have the perpendicular bisector of each side. So my line's going to come down like so. So it's pretty close there. Not perfect, I know. So those are all perpendicular. Those are all 90 degrees. We're bisecting each side. We're cutting it in half. So there's our circumcenter, this point right in the middle. And if we draw these segments to each vertex, all the red segments are exactly the same length. So I could put 4 marks on this. So if we have the perpendicular bisectors to each side of a triangle, they meet at a point, and that point is exactly the same distance from each vertex. We call that point the circumcenter. The questions on what the circumcenter is. All right, I want to go through, show you how to construct the circumcenter and construct the circumscribed circle. So if you have a compass and straight edge, you can follow along. Otherwise, if you go back to the video will show the tools for constructing this. It's all constructions that we've done before. We're just putting them together. All right, so the construction. I'm going to write down our steps. So to construct the circumscribed circle, we're going to construct perpendicular bisectors to 2 sides. Those 2 perpendicular bisectors are going to meet at the circumcenter. The radius is going to be from the center to any vertex. So let me go through this construction. All right, so there's my triangle. We're going to draw a circle that fits perfectly around this triangle. So I'm going to construct a perpendicular bisector at 2 sides. Our perpendicular bisector construction. That's the one where we make sure our compass is open more than halfway across one side. Draw an arc there. We're going to come to the other side of the triangle. Draw the same arc. And I need to make this one a little bigger. There we go. Connect those. That's the perpendicular bisector of one side. Now I'm going to do the same construction on another side. So I'll do that on this side. I'll do that one in blue. So go to this side. Open up more than halfway. Make an arc. Oops, it made the entire circle. Go to the other side, make an arc, and we're going to connect those two. Hello.
I need an angle.
Okay. And now we're going to connect those two. And where those two meet is the circumcenter. So those two lines are going to cross, those two segments are going to cross. And now my radius, I'll do that in green, is from that center to any vertex of the circle. Or sorry, any vertex of the triangle. So I go from the center to the vertex, and now I can draw my triangle. And if we do it perfectly, it touches each vertex of the triangle. So the triangle fits perfectly inside that circle. So we construct two perpendicular bisectors where they meet is a center, and the radius is from the center of the circumcenter to any vertex. And then we have our circumscribed circle drawn around our triangle. Questions on the construction? Construct two perpendicular bisectors. Radius is from the center to any vertex. And that's our circumcenter. And this point is the same distance to each vertex. All right, so that's our point of concurrency when we're dealing with perpendicular bisectors. Now let's talk about the angle bisectors. That was the other kind of bisector that we talked about. And for this, we're going to get the incenter. So for the incenter, we're going to look at the angle bisectors. And what do the angle bisectors do? Bisect means what do we mean by bisect? Cuts in half. Angle bisectors are cutting the angles in half. So the angle bisectors of a triangle are concurrent at a point. They all meet at one point. And that point is equidistant. from the sides of the triangle. The point is called the incenter. It is the center of the inscribed circle. And by inscribed we mean drawn inside. So this is a circle that's going to fit perfectly inside a triangle. So let's draw a picture of our incenter. So for the incenter, we're talking about the angle bisectors. So we'll try to get this to look good. And when we're saying the angle bisectors, we're saying we're cutting all of these angles in half. And now if we draw the distance to each side, what direction do we want to go towards the side to find the distance? What direction do I want to walk towards the wall to go the shortest distance? Straight. And by straight we mean we make a 90-degree angle. So if I draw the segment, it goes 90 degrees to any side. And I know my drawing isn't perfect, so I have to go by what the drawing is labeled, not how it looks. All of those segments would be congruent. So this point is exactly the same distance from each side of the triangle. So if I draw a circle here, it would exactly touch just those 3 points on the inside of the triangle. And we call that the incenter. All right, questions on what the incenter is? Yes? The dot itself is the incenter.
And
The circumcenter is the dot. Well, the circumcenter, so the circumcenter comes from the perpendicular bisectors, not the angle bisectors.
Oh, okay.
That was the difference, right? So and the circumcenter gives us the center of the circle that's going to be outside the triangle. The incenter is going to give us the center of a circle that's inside the triangle. Okay? So it can be a little tricky, but the circumcenter comes from the perpendicular bisectors. The incenter comes from the angle bisectors. All right, so let's construct the incenter. Very similar construction. We just have one extra step, really, that we have to do. So we're going to construct two angle bisectors. And and we've learned that construction already. They're going to meet at the incenter. Now, because our distance is perpendicular to the sides, we have to construct that perpendicular segment to one side. So we're going to construct to one side. And that construction is our smiley face construction. The length of that segment from the center to the side is going to be our radius. So that's how we're going to find our radius. So we construct that segment, we open up our compass from along that segment to the side of the triangle from the center, and that's going to give us our center. So let's do this construction. And now if you're following along on your own paper, make the triangle not huge but not tiny, because our circle goes inside the triangle. So if your triangle is really small, it's hard to get that circle inside. All right, so let's start by constructing two angle bisectors. So grab my compass. Angle bisector construction is the one where we start by drawing an arc across the angle. Then we move the compass. We put our points where the arc goes across the side. Make sure our compass is open more than halfway across the angle. That's not far enough. That's good there. Draw an arc here. Take it to the other side of the arc on the angle and draw another arc there. And connect the vertex to where they cross. We're going to extend it out a little bit there. We want to find where they meet. And now we're going to bisect another angle of the triangle. So I'll do this one. You can do any of the other ones you want. I'll do this one in blue. Make an arc across the angle, any arc, doesn't matter. Now we move our compass to where the arc crosses the side. Make sure it's open more than halfway, looks good. Make an arc. Go to the other side. Point where the arc crosses the angle. Drew my whole circle, that's okay. The vertex to where those two cross, and there's my incenter. So that's the center of my circle. Now we need to construct a perpendicular segment to one side of the triangle using our smiley face construction. So I'll do this side. I'll do that in red. So put the point on the center, our incenter. Our smiley face just needs to cross our segment. So there's our smiley face. And now we're just going to do the bisector, the perpendicular bisector of the segment made by the smiley face. So we just did those constructions. Open up more than halfway. Make an arc. Go to the other side of the segment. Make an arc. And we'll connect that to the center. There's our perpendicular bisector. And our radius is going to be the length of, I'll highlight it here, the length of that segment. So that's our radius for our incenter. So set my compass there. So there's my radius, and if I do this perfectly, this one's a little harder to do perfectly. If I do it perfectly, my circle should end up perfectly inside my triangle. So somewhere I did something not quite right with my construction. My circle should fit perfectly inside the triangle. This one's a little harder to get perfect. I think something happened with this angle bisector, it looks like. But that's the steps for that construction. All right, questions on that construction? And when you get it right, it's kind of nice because your circle fits perfectly inside the triangle. All right. The incenter is always inside the triangle. So for our circle to be inside the triangle, the incenter has to be inside. The circumcenter can be inside, outside, or on the triangle. We have three possibilities. If we have an acute triangle, our circumcenter is inside. So let me draw it. This is not necessarily going to be perfect, but we get an idea of where our incenter is. So our incenter is inside. If we have a right triangle, our incenter turns out to be on the triangle. So if I draw my perpendicular bisector, what's going on with my triangle? If I have a right triangle, my incenter turns out to be on my triangle. And if I have an obtuse triangle, the circumcenter is outside the triangle. So my circumcenter would end up being somewhere over here. So our incenter always inside, circumcenter can be inside, outside, or on the triangle. So the last thing I want to do is go through a couple of examples, the kinds of problems that you might, that you're going to see on a quiz or a test that they'll ask you to do on homework that have to do with the incenter and the circumcenter. So questions before we go on? Okay. Actually, I want to do this. I want to get a get a graph. Let me get some graph paper here. There we go. All right. So for this example, we're going to do we're going to draw a triangle on this graph. So here are my axes. And we're going to put one vertex up here at 0, 4. One vertex at 8, 0. And one vertex here at the origin at 0, 0. So there's my triangle. And the question says, find the circumcenter. Of this triangle on this graph. So for the circumcenter, do we look at the angle bisectors or the perpendicular bisectors? Which one is it, Sam? Perpendicular bisectors. So let's pick the easy sides first. We want to bisect the side, so let's look at this side. What point is at the middle of this side? What point cuts this side in half? What's halfway between 0, 0 and 0, 4? 0, 2. There's the point 0, 2. And if we want to be perpendicular to that side, which direction do I need to go? What's going to make a 90-degree angle with the y-axis? Across. So straight level with the x-axis, right? So I'm just going to draw a line straight across. So there's my perpendicular bisector. Let's look at this side. What point is halfway between 0, 0 and 8, 0? 4, 0. And which direction do I go to be perpendicular to the x-axis? Straight up. There's my circumcenter where those 2 points meet, right on the hypotenuse of that triangle. So what is that point? If this is 0, 2 and this is 4, 0. 4, 2, I go over 4 and up 2. 4, 2 is the circumcenter. So if we have a graph, if we have a nice triangle on a graph, we can use the graph to find our circumcenter. Questions on that example? All right, let's do one more quickly. I don't want to do that. So for this one, I'm just going to draw a picture. It doesn't necessarily have to be on. Well, let me get a different page. right, so for this example, here is our triangle. And we have a bunch of stuff going on with this triangle. And we're going to say that these angles are bisected. And I'm going to draw some perpendicular segments here. And we'll give these some names. So this is C, B, A, F, E, D. And we know that GB, this point is G. GB is 8x minus 7, and GD is 5x plus 8. And for this one, we'll just say find x. So here are the points, here are the segments that we're looking at. So because these are all angle bisectors, what do we know about point G? It's where all three of the angle bisectors meet. So what do we know about point G? It's the middle, which, so it's one of the centers. The incenter, good. The incenter is the same distance from each, what, of the triangle? Side. Well, here's a distance from the side of the triangle to the incenter. Here's a distance from the side of the triangle to the incenter. So what do we know about those two distances? They're equal, they're the same. So 8x minus 7 equals 5x plus 8. And we're home free. Subtract 5x. So we get 3x minus 7 equals 8. Add 7. 3x equals 15. Divide by 3. And x equals 5. So because this point is at the incenter, it's where all three angle bisectors meet, it's the same distance from each side of the triangle. All right, questions there? Okay, let me give you your homework. Let me write down your homework, and then we'll go over last night's homework quickly before we finish. All right, there you go. And stop this.